Hey guys, welcome back to my YouTube channel. We're still under fluid mechanics. This is N6 flow in pipes, right? With the question reaches for 1.4 says a pipe with a particular diameter discharge a petrol with a relative density of, they've given a relative density of 0.78 at a rate of 87 cubic meter every hour and at a velocity of 9 meters per second. So right is what we are given there. That is what we are given. We're given there 0.7 and also are given 8.7. This is q and the velocity there. We have the velocity 1.4.1 says determine, supposed to determine the density, which is, we know that is P, right? Which is the density of petrol. We want the density raw. Okay, now what do we have? A relative density is the same as specific gravity. Relative density, this is the same as SG. It's the same as relative density. The same as relative density, right? The relative density is the same as specific gravity. Okay, now let us answer the question. Says determine the density of the petrol 4.1. Let us determine the density of the petrol, right? We know that the density which is raw, the density of the subs will be equal to 1000, right? Or we can say 0.78 multiplied by 1000 multiplied by 1000. Remember, this is the density of water. This will give us, when you multiply, this will be 780, right? Kgs. This is measured in kgs per cubic, right? This is it is a density of the substance. That is the density of the substance, right? This is the density of the substance, right? What we are given 1.4.2, the diameter of the pipe in millimeters. They want the diameter of the pipe in millimeters. We're given a pipe. It's a single pipe. You see the single pipe with a particular diameter discharge relative density of at a rate. Okay, we know this is this pipe. We have a pipe. This pipe, there's a petrol that is flowing here in this pipe. So that means we have Q. We're given Q. We have the rate. We are given the rate. Then we can use the rate. We know the rate is equal to area multiplied by velocity. Then we can make an area the subject of the formula, because we know we can find the diameter on the area of this pipe, right? So you want the area, can write one the area. We know that here we have, this is 1.4.2 So 1.4.2, right? So want the diameter, then we'll make the area the subject of the formula. We know that area will be equal to Q, the rate of flow, right? Divide by what? Divide this by the velocity of flow. Now we want to find what is Q. We're given Q to be 87. You see that is 87 cubic meter per hour. Now we want it to be must be in cubic meters per second. That means we'll divide that, remember, 60 minutes, right? 1 hour will multiply by 60 minutes, will be in minutes, and also will multiply this by the 60 minutes, so that will convert. Actually, let me show you. We'll convert this. We know this is in hour, right? 1 hour. It's 1 hour. Then we'll multiply this. Want to convert these hours to be in seconds. We'll multiply this by 60. This will be in minutes, right? This will be in minutes. Now we want to be in seconds. We also multiply again by what? By 60, right? That means we'll divide by this. We'll divide 87. That 87 we have there. That 87 that we have will be divided by this. We'll divide this 87 and divide this 87 by all of these. We'll divide this 87 by this, right? Right. This is how we will convert that. When we convert that, this will be equal to, when you punch on your calculator, Q will be 0.02417, right? This is when you divide that, will be like this in cubic meters per second, right? So we can divide. We know our Q will be 0.0, right? And we'll have 2, then will be 417 over the velocity we were given, which is 9. If here is your velocity here, is 9. Velocity we are given is 9 meters per second, right? Then punch this on your calculator. Supposed to get that the area must be equal to, punch that on your calculator. You're supposed to get that to be 0.02685, right? This is what it's in area, but we want the diameter. Now, since we want the diameter, we know that area is given by pi d squared d squared over 4, right? Then this will be equal to 0 comma 0.02685, right? We'll make the subject of the formula d. We'll make d the subject of the formula, right? You'll multiply by 4 that side and divide by pi and take the square root. So if you make the subject of the formula, you're supposed to find that d will be equal to 0 comma 0.585, right? This is in millimeter, it's in meter, must be in meter, right? Now if you want to convert this to be in millimeters, you multiply this by 1000, you multiply this by 1000, right? Yes, you multiply this by 1000, the diameter d will be equal to 58 comma 47 millimeter. This will be in millimeter, right? This is our, it will be a diameter. This is our diameter, right? So this will be our diameter, right? So we have last question, says that this last question, we determine the friction head. Supposed to find the friction head there. The friction head, we know that friction head is HF, right? We want the friction head. If the pipe is new, they use the new pipe and clean, okay? All right, and its coefficient of friction is this. They state we're supposed to use this to find the coefficient of friction because it's a new pipe and clean pipe, right? They're giving us and it is 4 kilometer long. That means is the length 4 kilometer long. That means it will be 4 times 10 to the power of 3, right? This will be length, and this will be in what, in meter, convert that kilometer. So let us find HF. When we calculate HF, we know that HF must be equal to 4FLV squared divided by 2GD, right? This is the formula. This is the formula we will use to calculate that. This is a formula we will use to calculate HF, right? So we can substitute. We know that will be equal to, we have 4, but now we don't know F, right? So we're supposed to calculate F using the formula that they said we should use, the one that says we know most F F for the new pipe will be 0,00, right? Be 0,005, right? This will be 1 plus 1 over 40, diameter. Then this will be diameter. All this will use this. Then our F there will be 0,005. That is 1 plus 1 over 40. Then we have the diameter there. Remember, we have the diameter we've calculated, which is 0,0585, right? That was the diameter. We had the diameter, isn't it? We had the diameter. Let me move this. We had the diameter. We had the diameter, which is 0,058,5. That is the diameter, right? That is what that was, a diameter. Then we multiply all of this. Then when you punch your calculator, 0,005 into 1 plus 1 over 40, multiply this. Punch there. We're supposed to get that our F must be equal to, what is that? 0,0071, 0,071, right? That is what I called 0,071. All right. This is coefficient of friction. Now we have the coefficient of friction. We can simply calculate now. Since we have the coefficient of friction, we can simply calculate our frictional head of friction coefficient, or head loss due to friction. This is the formula we have to apply there. Head loss due to friction. I'll move this formula down here. That is what we have to apply there. Head loss due to friction, right? This will be equal to HF must be equal to 4 into 0. We have calculated, we found that is 0,071, 0,0071, right? What about the length? Is the one that we've calculated it there on the top. Remember, the length, we're given the length to be 4,000, is 4,000. It was 4 kilometer, right? This will be like 4,000. It was 4 kilometer. Then this will be 4,000 converted to meter, multiplied by the velocity, which was 9. Then we'll square the velocity. square the velocity, then we divide this by 2 into 9,81 multiply by the diameter is the one that we have calculated, which is 0,0585, right? Then we punch this on your calculator. Punch this on your calculator. If you punch this, you will get that HF. Get that HF is equal to HF will be equal to 8063,59 meter. This is your answer, and this it is HF, right? Then we're done. Here it's our calculations. We have found the density. Here is the density, 78 kg per cubic, and then the diameter of the pipe. Here is the diameter of the pipe. We found the diameter of the pipe. Here is the diameter of the pipe, right? Then the last one is this one. Thank you guys for your time. Do not forget to subscribe to my YouTube channel, as I'll be posting some new videos.